Okay, so in this section we're looking at integration by parts. Alright, we're going to look at integration by parts doing it the normal way, and we're going to look at something really cool called integration by parts by the tabular method, which saves you a ton of time, but it only works in certain cases, so I can't teach you just that. Okay. Alright, so I want to integrate x times e to the x. And so if you notice, if you try to do u substitution and let u be the exponent, then du is just 1, and if I tried to replace that, I have this extra x right here, and you can't pull an x on the outside, like I can't do that, that doesn't work. I also can't cancel out an x, with the 1 over x. I can only manipulate things by, a number. I can't do anything with a variable, so that's not going to work. Okay, so when that doesn't work, we have to go with integration by parts, or try integration by parts. Alright, look at your two functions in here. I have an x, which we're going to call that's an algebra, and I have an e to the x, which is an exponential. So when you want to try use substitution, you go in this order and you say, all right, I need to go in the order of, do I have any logs first? Well, I don't have any logs, okay? And then after logs, it's algebra. Well, I do have an algebra, so that tells you what to let u be. So you draw in your box, and in your box you say u equals du equals v equals dv equals. Alright, so I'm letting u be algebra, so whatever's left over gets to be dv. Now you fill in your box. So if you've got u, du is just the derivative of that. That would just be 1 dx. Okay, so you take derivatives down, but if you've got dv, you want to integrate, but you know the integral of e to the x is just e to the x. Don't worry about a plus c. And then your answer is just plug and chug uv minus the integral of v du. So let's plug in. So u is x, v is e to the x, minus integral of v, which is e to the x, times du, which is 1 dx. So then my answer is x e to the x minus the integral of e to the x dx. So that's x e to the x minus, we know to integrate e to the x, you just get e to the x, and now you put on your plus c. So integration by parts is not bad. Alright, let's look at the next one. Okay, so I've got the integral of x squared times the natural log of x dx. So I've got two functions. I've got an x squared, which is an algebra, and I've got a natural log of x, which is a log. So again, I'm going to draw my box right here this time so I have more room. U, du, v, dv. You get to pick u, and you go in the order logs first. So there we go, which makes this be my dv. Alright, so if I have u, du is just the derivative. The derivative of the natural log of x is 1 over x dx. And if I want to, I have to integrate when I go up. So integrate that, I get 1/3 x cubed for v. So my answer is uv minus the integral of v du. So let's plug in u v minus the integral of v du. Alright, so let's clean it up. Alright, now what you cannot do is multiply that x and that x cubed. Does not work. Please don't do that. Just throw that on front and keep the natural log of the x in the back. Okay, I'm going to pull out this 1/3 right here, and I'll show you why I do that in a minute. And now be careful, if you're going to cancel, one of these x's cancels, and that leaves me with 2. Okay, if you will always take this number, pull it on the outside like I do, then with you're left to integrate with what you've already integrated right here. So then it's real easy to say, alright, well, the integral of that is 1/3 x cubed, and then plus c, and then you just have to multiply that out. 1/9 x cubed plus c. Okay. Alright, and then let's keep moving. Next. Alright. Draw my box. U, du, v, dv. Okay, So the problem here is that I only have one kind of function. I only have that, which is a natural log. I probably didn't make my box big enough, but we'll go with it. Alright, so but you have to put something left over. Well, the only thing left over is just 1 dx. Okay, so if I fill in the rest of the box, remember to take the derivative of the natural log. It's what's behind the ln, and then the derivative of that on top. So I just get 1 over x dx is the derivative of that because those 7's cancel. And then to integrate 1, you know it's just x. So uv minus the integral of v du. So natural log 7x times x minus the integral of v times du. Okay, so again, you cannot mix that x and that 7x, just throw that x on the front. And then what happens to the x's? They cancel, and I'm integrating just 1 dx. But again, that makes me feel good because that's what I had right here. So this is just x natural log of 7x minus x plus c. Now, the next example, if you notice, I'm going to skip it right now in your notes. We're fixing to do it. It's the same exact problem. Number 4 and number 5 are the same exact problem. If you did it on the paper right here, you have to end up doing 2 of these boxes. And you don't want to do that. You want to use the tabular method anytime you can use the tabular method. So I said, all right, we can use the tabular method if U is in algebra. Okay, so like in this one, I have an x squared, which is an algebra, and I have an e to the x, which is an exponential. So anytime my u is that algebra, and I go in the order LAE, so this one is no L's, so I have to go with u as A, you want to use the tabular method. Okay, it's wonderful. You're going to make 2 columns, a u and a dv. U is your algebra, and then whatever's left over is your dv. Okay, so you're going to take derivatives down to 0. So you keep taking a derivative until you get a 0. So derivative of x squared is 2x, derivative of that is 2, the derivative of 2 is 0. That's where you stop. Now what you have to do is even out your dv column. You integrate. Alright, so if I want to integrate negative e to the negative x, I can just get a negative e to the negative x. Each time, all I'm doing is multiplying by the derivative of the exponent. So if I multiply by another negative, I just get e to the negative x, and if I multiply again, I get negative e to the negative x. So each time, I'm just multiplying by the derivative of that to integrate it, and it's fast, okay? So you're going to even out your columns. Then you're going to match them up. You're going to say, alright, this top one goes with this one, this 2x goes with this one, and this 2 goes with this one. You never use this one or this one, okay? And then you put in signs. You always start with a plus, then a minus, and then a plus. So what you do is you multiply the endpoints of those blue lines with that sign. So I have a positive x squared times a negative e to the negative x. Alright, then my next line has a negative in the middle, and I have a 2x and an e to the negative x. And then I have my positive 2 times negative e to the negative x plus c. There's no table, there's no other integration, you just need to simplify that all out. So I get negative x squared e to the negative x minus 2x e to the negative x plus minus, missed a sign, minus, oh no, let me start back. Okay, minus 2e to the negative x plus c. And it's so much faster than if you had to do that out twice. Okay, let's try another one. Alright, so again, this is my algebra and that's my exponential. So I'm going to make 2 columns, a u and a dv. So my u is 5x plus 3, which makes this dv. So again, take derivatives down to 0. So derivative of 5x plus 3 is just 5x, and derivative, no it's not. Sorry, what is the derivative of 5x plus 3? It's just 5, and the derivative of 5 is 0. Alright, so to integrate, each time I'm going to multiply by the reciprocal. I misspoke a minute ago. You want to multiply by the reciprocal of the derivative. So each time I'm multiplying by a half, okay, so it would be 1/2 e to the 2x. If I multiply by another half, I get 1/4 e to the 2x. Okay, but you could actually write it out and integrate it if you want to, but each time you're just multiplying by the reciprocal. And I didn't say reciprocal before because it was just that sign that we were using. So let's join them up. So these two go together, and these two go together. Remember, you don't use that one or that one. And this one's a plus, and this one's a minus. Alright, so I need to multiply 5x plus 3 times 1/2 e to the 2x, and that's a positive, and then this is a minus line, 5 and 1/4 e to the 2x. Okay, so what I'm going to do is take this 1/2 e to the 2x and distribute it. So I get 5/2 x e to the 2x plus 3/2 e to the 2x minus 5/4 e to the 2x plus c. Now if you were looking at that, you might not see that answer because these two are like terms and can go together. So 5/2 x e to the 2x, so I need to do what is 3/2 minus 5/4. Well, that would be 6/4 minus 5/4. So that would be 1/4 e to the 2x plus c. Okay. So look for those like terms. And then we'll do this last one. Alright, so now it has limits of integration. It's a definite integral. Alright, I have an algebra function and a logarithmic function. If I have a log, I cannot use that great tabular method. I have to go back to my box. Okay, so u, du, v, dv. Alright, u is natural log 3x. So the derivative of that, remember, is what's behind the L on the bottom, derivative of that on top. So it's just 1 over x dx. And then dv became x cubed. So if I integrated it, I get 1/4 x to the 4th. Okay. Alright. uv minus integral of v du. So natural log 3x times 1/4 x to the 4th minus the integral of 1/4 x to the 4th times 1 over x dx. Alright, so I get 1/4 x to the 4th times the natural log of 3x minus, alright, remember, I'm going to pull that number out. 1/4, and then one of those cancels, so I end up with x cubed dx. So I get 1/4 x to the 4th times the natural log of 3x minus 1/4 times 1/4 x to the 4th, and I'm not going to write plus c. I'm going to say 1/16 x to the 4th. Alright, so we know we got to plug in, and I'm going to run out of room. Let's see. Okay, so I want to go from, what did it tell me my limits of integration were? 0 to 1. So it would be 1/4 times 1 to the 4th times the natural log of 3 times 1 minus 1/16 times 1 to the 4th. And here, 1/4 times 0 to the 4th times the natural log of 3 times 0 minus 1/16 times 0 to the 4th. But multiplying this whole thing by 0 makes that go away and that go away. So no, that's just 0. So this would just be 1/4 the natural log of 3 minus 1/16. And you, if it didn't want that answer, just plug it in your calculator and see what that is. Alright, so go practice some homework.